I work as DevOps engineer for AWS Squad in CloudOps team. As a DevOps engineer, my work goes around developing the cloud infrastructure and managing the core of infrastructure and its application. Today, I will be explaining about my experimental tool Kubevirt, which are used for VM orchestration and their provisioning. In current scenario, VMs are being provisioned independently on our OS and they use the memory provided by the host. This may lead to overutilization of resources and memory, which can lead to downfall of the application or to the host on which it's running. In this case, Kubevirt comes into the picture. Kubevirt basically means to deploy the VMs alongside containerized application in Kubernetes environment, so we can manage the cluster along with the VMs and application. Kubevirt basically runs as a add-on or as a group plugin on our Kubernetes cluster. It basically uses the memory provided by the Kubernetes node, or you can say the cluster node which we are using. Using the node memory, it is provisioning objects running inside the VM, and it's not taking any memory from the host. So the cluster is acting as a hypervisor above the Kubevirt. Kubevirt allows users to run VMs as any other Kubernetes object in the cluster using APIs and YAML files. Kubevirt uses the memory of node. So once the VM is done with its memory, Kubevirt returns the memory to the hypervisor, which helps in memory optimization. And also, since Kubevirt is running as a different the Kubernetes cluster, it does not affect any other container or pod running on the cluster. Kubevirt is using node as the host. It does not consume any memory provided by the host, and it leads to the memory optimization for host as well as the Kubernetes node. Since Kubevirt provisions VM using Kubernetes API, it does not require manual instruction for creating VMs. Rather than, we can create a single YAML file and VMs can be provisioned using it. And for further deployments or any other changes related to the VMs, we can make changes in the YAML itself, and it can be further reconfigured into the VMs. So it basically eases the work of automating the VM provisioning rather than managing them manually. Let's take a look at the implementation and working of Kubevirt tool. First of all, we have to enable nested virtualization on our host. Since it's using the memory of VMs, so we have to create nested virtualization as cluster is running inside the VM of our host. Then we have to create a Kubernetes environment. So basically, we can use Kubernetes environment provided by Minikube, AWS providers like KOps, other Kubernetes platform like Kind for provisioning Kubevirt. In case of Minikube, since it is provided as an add-on, we can directly use it as an add-on. But in case of other providers, we have to install it using Crew plugin. After that, we have to enable container runtime, which can be Docker or containerd. So container runtime is being used because we are running the cluster or our Kubernetes environment within the container. After that, the setup setup components consist of the Kubernetes architecture. Now the thing is that Kubevirt is running as an independent application within our Kubernetes cluster. So it will not be using any components provided by the Kubernetes cluster. We have to create components for it separately. So those components include Kubevirt controller, Kubevirt API, handler, and virtual launcher. Virtual launcher is the one that is used for that controls the launching and provisioning of VMs. And for command utility tool through which we communicate to the Kubevirt is virtualctl, which is again provisioned like a pod in a Kubernetes cluster. After that, basically we write a YAML file for creating the VMs, and we simply run it using kubectl apply or kubectl create -f, and we provide a path to that YAML file. Once we run it, the VMs are getting provisioned. It runs first the VMs, then the virtual machine instance inside the pod, and it basically sets up the VMs for inside the Kubernetes cluster. So this is the architecture explaining how Kubevirt tool works in Kubernetes cluster. So basically, Kubernetes consists of two nodes. You can basically set up single node cluster or multiple node cluster. In our scenario, I have used master node and a worker node. So on master node, Kubernetes control tool works through which we communicate to the Kubernetes cluster. Under that there is API server, virtual machine controller and the virtual machine API. We give instruction to the API server. API server instructs the machine controller to check if there is any provision check if there is any provisioned VMs on the worker node or not. If it is, then it sends the instruction back to API server that yes it is. If not, then it again instructs the virtual machine API to communicate it to the worker node to provision node. Then once a worker node receives the instruction about provisioning the VMs, it provisions the VMs as pod using virtual machine launcher, which itself is running as a pod. Virtual handler running on the worker node basically keeps on checking whether our VMs which are provisioned at VMI on our worker node are up or not. They do it with the help of virtual machine API running on the master node. If they fail, virtual machine API again instructs the API server. API server again instructs the kubectl to keep the VMI running. If the VMI is down, virtual launcher won't be running. And same goes for other application running on the Kubernetes cluster also. Now I will be explaining some of the use case and application of Kubevirt 2 in efficient resource utilization. Running VMs alongside containerized application can help better utilize available resource in a cluster. Because Kubevirt is basically running VMs alongside our applications, so we do not need to provision separate memory for running our application and VMs. It will basically use the memory of the node itself only. So in this case, it will help in better resource optimization. Second one, complex management. In previous cases, VMs were provisioned separately than the Kubernetes cluster, so it was very complex to manage all of them. In this case, Kubevirt helps in overcoming this, because in case of Kubevirt, we are basically provisioning our application and VMs inside the Kubernetes cluster, which allows us to centrally manage both of them together. Kubevirt allows users to manage both types of workload using the same tools and APIs. Like I said, in Kubernetes cluster, we can provision VMs alongside containerized applications. So we can create a single YAML file in which we can basically declare an application and also the VM. And since it's using the same kubectl command line tool for running those YAMLs, so they can be provisioned using the same YAML file. It basically eases the complexity of writing multiple YAML files for managing application and VMs. Also, Kubevirt provides security for VMs. Since we are creating VMs using YAML file, we can basically declare secrets for login into VMs, which can enhance the security of provisioning the VMs using Kubevirt tool. Now I will be explaining how Kubevirt tool provides value addition for VM orchestration and application deployment. In case of Kubevirt, since we are provisioning VMs using the memory provided by node, so customers do not so using them, we do not need to consume the memory of the host or the OS on which we are running the cluster. We can basically provision the VM alongside our other application, like any deployment or any server, along with managing the VMs through same centralized place. Also, since Kubevirt is deploying VM using YAML files, we can manage them and make changes or reconfigure them using common YAML file. Now I will be explaining how Kubevirt tool can be used in our day-to-day work. For example, suppose we want to provision some testing workloads. In those cases, we have to provision a VMs for running them, since we don't want to use our host memory. Now we have a Kubernetes cluster which is not using complete of its memory, and there are some memory always left that can be used for running other workloads as well. So in such cases, we can basically use Kubevirt inside the Kubernetes cluster for running our VMs. So now as VM is running inside our Kubernetes cluster, we can basically use those VMs for running our workloads. We do not need to provision a separate VMs, as it may lead to resource consumption. And since it's using the memory provided by the Kubernetes cluster, provided by Kubernetes cluster, all the resources inside our Kubernetes are also getting used rather than getting wasted. I have worked on Kubevirt tool as part of Experimental Saturday. I am very thankful to XenonStack for providing me this tool. It's a very great initiative. Since being a DevOps engineer, I always have to cope up with the marketing standards and skills and develop my skill set for running various applications and deployment. One such use case is orchestrating and provisioning of VMs. Like I said, since Kubevirt can be used for provisioning VMs inside our Kubernetes cluster, so it can basically involve complete DevOps practice rather than provisioning Kubevirt as a separate entity in our host. Thank you for watching this video.